Hey everybody, welcome to the last section in PreCalc. This is actually my favorite, 12.5, the binomial theorem. Before we get started on this stuff, let me just make sure everybody knows what a factorial is, which you may not, that's okay. It's an exclamation point after a number. So like n factorial. So what you do when you have n factorial is you start at that number and multiply all the way down until you get to 1. So like it would be n times n minus 1 times n minus 2 times blah 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 until you get down to 1. And that's how you do n factorial. So for example, let's say we had 6 factorial. So if you have 6 factorial, you could do 6, 5, 4, 3, 2, 1. That's for real how you do it. So in your calculator, you can do it the long way. We're doing 6 times 5 times 4 times 3 times 2. And you don't really need to do the 1 because it's just itself. So you get 720. Another way to do it, and there actually is ways to do it on both scientific and graphing. I don't know what kind of scientifics you guys have, so it's hard to say. But, like, so I'm doing 6 factorial. So I'll type the 6. I go into the math, and this is actually a probability thing. So I arrow over to probability, and then number 4 is your exclamation point. So you just hit that, and then hit enter, and there's your answer. So you don't have to go and do the whole thing. And I know there's scientifics that have the factorial as well. A lot of times it's right on the front of the calculator. So again, it's one of those cases of just knowing your own calculator. All right, so the first concept we're gonna do is sorry, just want to get myself on the right page. Okay, so we're going to evaluate these funky things. And it's a big parenthesis with a number on the top and a number on the bottom. So this is n things taken j at a time. That's how you read that notation. It's a little different. So, and here's how it works. N things j at a time. It's n factorial. Separate those. N factorial over j factorial times the difference between the two. N minus j factorial. And the thing that works for me with this number plus this number adds to this number. Let me show you what I'm talking about. Let me do number 6. All right, number 6, we have 7 things taken 3 at a time. I forgot to put the focus on. There we go. 7 things 3 at a time. All right, so that'll be the top number factorial, so 7 factorial over j is 3 factorial, and then times the difference of the two. So it'd be 7 minus 3 factorial, but remember this was this, add to that, so it's 7 factorial over 3 factorial, 4 factorial. Okay. So one way you can do this is by writing it out, and things will always cross out. So 7 factorial, we have 7, 6, 5, 4, 3, 2, and 1. With 3 factorial, we have 3, 2, 1. 4 factorial, we have 4, 3, 2, 1. See how all these line up? Not a coincidence. Alright, and then you can start crossing stuff out. So for example, at the end there, you have the 4, 3, 2, 1. They'll cross out because you have 1 on the top and 1 on the bottom. And then you have 3 times 2 on the bottom, which is 6. So 3 times 2 cancels out and 6. So you can do a bunch of calculations there without even busting out a calculator. So you're just left with 7 times 5 over 1, which you don't really need. So 7 times 5, which is 35. There is another way of doing this. And this is a probability thing. But 7 things taken 3 at a time can be written with a big C, and then 7 things taken 3 at a time, like a committee. That's also on that same screen where factorial is. It's a heck of a lot easier to do this than to go through any of this. And this is another thing that's also on scientific calculators. You're just going to have to find it on yours. Oh, I should look at my phone, but I'm videoing with my phone, so I can't look. So I'm going to go math, arrow over to that probability screen. There's NCR right there on number 3. So I'm going to hit that. It gives me the blanks. So I do 7 things, 3 at a time, and there's my answer of 35. That's a heck of a lot easier than going through all that other stuff. Okay. Let's look at number 10. Wish this paper didn't bleed through. It'd be a heck of a lot easier just to go to the next piece of paper. I'm running low. I wish I got more from school too. Oh well. Alright, number 10. We're doing 100 things 98 at a time, which sounds painful because you think, oh my gosh, that's going to be 100 factorial on the top. Again, you can use 98C 100, or sorry, 100C 98 if you want. This one actually is not bad to do if you do a shortcut. So you have 100 factorial and then 98 factorial and then the difference factorial. 98 factorial is inside of 100. So just rewrite it as 100 times 99 and then stop at 98 and just call it 98 factorial. I'm going to put this 98 factorial right under that one. And then our other one is 2 factorial, which is 2 times 1. So what happens is your 98 factorials cancel out. And then you're just left with this. And 2 goes in 150 times. So really the only thing you're doing on this one is 50 times 99, which is 4,950. So just kind of a shortcut if you are doing it by hand. This is kind of one of those topics. You're going to have to make it your own. Like what works best for you. Alright. This is my favorite part of this whole thing. Is Pascal's triangle and how it works. There's so much you can do with this little triangle. Well, big triangle. Alright, so Pascal's triangle works like this. You start with a 1, and then underneath it you have 1 and 1. Okay, then underneath it you have, the outsides are always 1. In the middle we have a 2. So you might be like, where'd that come from? I'll show you in a minute. Next level, 1's on the outside. This will be a 3 and a 3. How did I know that? What it is your inside numbers are the sum of the 2 that are above it. So 1 plus 1 is 2. 1 plus 2 is 3. Excuse me. 1 plus 2 is 3 is over here also. Alright, so for the next row, I'm going to start with 1. Then 1 plus 3 is 4. In the middle, 3 plus 3 is 6. 3 plus 1 is 4. 1 on the end. I'm going to keep going. 1 to start with. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1. Every other row is going to have repeaters in the middle. One more row. I mean, this could go on forever. You could spend the rest of your life making the Pascal's triangle if you really wanted to. Okay, so we'll go to there. I'm going to do, the numbering on Pascal's triangle is always a little weird. It starts with 0. So the top number, that 1 on the top, is actually considered row 0. Alright, this one then is row 1, row 2, row 3, row 4, row 5, and row 6. Alright, now let me show you where, well, let me work some stuff out here, and we'll try to form some relationships. Alright, first thing I'm going to do is x plus y to the 0 power. So x plus y to the 0 power is just 1, because anything to the first power is 1. Anything to the 0 power is 1. Alright, next I'm going to do x plus y to the first. Anything to the first power will just be itself. So this will be 1x plus 1y. I'm stating it like that for a reason. I want you guys to see the relationship between this and Pascal's triangle. Excuse me. Next, I'm going to do x plus y to the second power. Alright, so this one would need some foiling out, because this is x plus y times x plus y. So you have x squared plus xy plus xy plus y squared. So putting those together, putting our like terms together, you have 1x squared plus that, and that would be 2xy plus 1y squared. Look at the coefficients. The coefficients here match up with row 2. The reason this is row 2 is its second power. Not the reason, but that's how it matches up. That's why this is the 0 power, because to the 0 power it's just 1. Pretty cool how that works. X plus y to the third. Okay, x plus y to the third is a big pain in the butt to do by hand, because you have to do x plus y times x plus y times x plus y. So you have x plus y, and then this x plus y times x plus y, we just did it. I'm going to use my answer, x squared plus 2xy plus y squared, and then multiplying these together, distributing the x, you would have x to the third plus 2x squared y plus xy squared. Then distribute the y. So y x squared plus 2xy squared plus y to the third. So when I put those together, when I put my like terms together, I do end up with a match with row 3. 1x to the third, x squared y. We have a 2 and a 1, so it'll be 3x squared y. The xy squared, we have a 1 and 2, so again 3 xy squared, and then 1y to the third. And I want you to notice what's happening with the exponents on the variables, because that's going to be important too. The x counts down, so the number in the front, or not the number, sorry, the variable in the front counts down. 3, 2, 1, then there's no x. The y counts up, starts with no y, then you have y to the 1, y to the 2, y to the 3. So if we were to continue this pattern, x plus y to the fourth, I am not going to sit here and multiply that whole thing out. That would be pretty painful. Just use what's happening. So you have a 1 here, 1, and x counts down, starting with 4. And it counts down to 0 and up to 0. So y is not in the first term. Plus, our next coefficient is 4. 4, x goes down to 3, y comes into the picture at 1. Plus, next coefficient is 6. X goes down to 2, y goes up to 2. Also, the powers always add to 4. So 4, 3 plus 1 is 4, 2 plus 2 is 4. So many patterns. Plus 4, x goes down to 1, y goes up to 3. And then your last coefficient, of course, is 1. X is now gone, and y is to the fourth. It's a heck of a lot easier to do it that way than if you had to do this one, you would multiply a trinomial times a trinomial, which is just a disaster. So it's really pretty cool that that works. All right, so let's use this in an actual textbook problem. Let's look at number 22. I know some of you kind of secretly like math, so like, hey, that is pretty sweet. I'm really kind of sad I don't get to teach this one in class. I'm just going to watch the, oh, that is pretty sweet. All right, so number 22. It's okay, you can secretly like math from afar. All right, so 2x plus 3 to the fifth power. All right, so the fifth power means we're going to use row 5. All right, so our coefficients from the triangle. All right, row 5, our coefficients are 1, 5, 10, 10, 5, and 1. Now this one is a little bit different because we have that 2 there, so we're going to have to deal with that. Well, it's a 2 and a 3, like this one's just kind of different. We have the screaming bird, and he just screams. Alright, so we start with our coefficient of 1. Our first term is going to be to the fifth. Include the 2 with the power to the 5. So it's more than just an x now. Now it's 2x to the fifth, whole thing to the fifth. This is not in the picture on the first term. Plus, next coefficient is 5. 2x will now go down to 4, but the 3 comes into the